Waalaikumsalam, sir. Yes, sir.
Bismillahirrahmanirrahim. So, insyaAllah, let's begin kita baca. Ya, alhamdulillah, rabbil alamin, wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Hadis adalah sendiri amalnya. Alhamdulillah, alhamdulillah. So, um, ya, alhamdulillah. Hope everyone is okay. Sorry for the info about the online class. um, First thing first, ada yang ni tak? Ada yang ada kelas depan, kelas pukul 10.
Sorry sir.
Ada sesiapa yang ada kelas pukul 10 tak?
Me, sir.
Orang.
I have class.
Okay. Sekarang kat mana? Kat dorm ke dekat
At my room.
Oh, okay. So try to finish early. So that siapa yang ada kelas after this boleh bergerak ke kelas hanya sebab apa dekat bilik lagi. Okay. I actually pagi tadi I try to look at apa at the assignment and then ada yang tak ramai lah yang dah turn in. Lepas tu cuba sekarang tengok orang dah ramai yang turn in. Okay, I want to discuss on it. Okay, cuma ada yang a few yang I saw ada silap sikit lah. Okay. 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 Okay, boleh nampak? Apa nama tu? Boleh nampak ke screen ada tulis yang apa? The solution on apa?
Nampak sih.
The assignment. Nampak? Okay. 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 So yeah, so we'll go through now. So actually from this question, ini actually from test 2 sem bila tu? Sem 2 semester back kot. Okay. Where basically this is from chapter on the second degree of freedom, 2 degree of freedom system, where we do model analysis, or we take a look at the modes. Okay, we how do you determine the modes from a 2 degree of freedom system? And so we'll go to the process. So the process basically in any system, um, of course this is limited to 2 degree of freedom system. Okay, so if 3, then it will be different. Process is still the same, but be different. Okay, process still the same. Basically what we have to do first. Okay, so now in this system over here, okay, so we have a rotational system, and we also have a translational system, right? So translational system is the one with the mass m, rotational system is the one with the sort of like a pulley here. Okay, so so um, so in any process of determining the modes, okay, by hand, okay, by hand, is that we have to find the natural frequency, and from there we take the algorithm, okay. So find the natural frequency and take the ratio. Okay. So basically, in terms of process, starting off to find the natural frequency is basically we need to have our equation to be in um, W equals to square root K over M, right? So we need to find this shape in order for us to get at the natural frequency, right? So okay, so basically over here, this is the solution and marking scheme, marking scheme for the question itself. So ni ada markahnya lah, so just ignore the marker. Okay. Um, okay, so first thing first is we need to derive the equation of motion. So how do we get the K and M is from the equation of motion, right? So I saw some uses the normal way, not normal way, the conventional way by FPD, and some also uses relay energy method, right? Um, Now, so this is using the normal method. Okay, is one is by using. So since we have two masses, okay, so two masses. So the pulley itself with the mass and the block M over here. So we have to have two equation of motion, right? So, and this is 2 degree freedom. So two equation of motion. So first one, we'll take this one first. Okay, so the first one is mx2 dot. So this is from the block M over here, which I'm sure you can. So this is basically the um apa secara ringkas lah, simple term. So M for the mass, for the forces acting on M, we have the spring force, and also we have the spring force or the spring force due to the displacement of x, and spring force due to the displacement of the pulley. Okay, so r theta, so this is S. Okay, S equals to r theta. Okay, so that's one. Okay, and then same thing for the pulley itself. So we have the spring, and we also have the as so the spring multiplied by the mass over here, or the rotation of the pulley. So we have one force over here acting over here, and another force acting over there. So just to simplify, so we will have one equation of motion due to the rotation, and one equation of motion due to the translation. Okay, so once we get the equation of motion, um, and since we have the j over here, but since we want k over m, right? So we want m, so j, so this mass moment of inertia. So mass moment of inertia for a pulley. So pulley is sort of we can consider as a uh, what is it? Thin, what is it? So thin cylinder. Okay. So for a cylinder, or for a thin cylinder, the mass moment of inertia is mr squared over 2. So this is a well-known, very common, very common question. Which I hope you Actually this one patutnya kena memorize kan, kalau ikutkan dalam, I think in mechanics of materials, I think you need, if I'm not mistaken lah, to memorize. So mr squared over 2. Okay, so we substitute this one, mr squared over 2 into both, in equation 1. Okay, so we substitute with J. So we have, I don't know. Okay, so we have this equation. Basically just substitute J with mr squared over 2. Okay, so okay, so we have these two equations. And then we substitute theta and x with the harmonic displacement, okay, or harmonic input. Okay, so harmonic input for theta is y cosine omega t. For x is x cosine omega t. Okay, so one thing that you have to make sure this one both are the same. Okay, so jangan pula satu cosine dan the one is sine. Okay, so you need to make sure that both are the same. So both are the same input, same sort of input for sine input. Okay, displacement or the amplitude should be different. Why? Because one is, so this is similar with some other examples where we put um, x1 equals to x1 cosine omega t, for example, and then x2 is x2 cosine omega t. So just in this case, we differentiate this alphabet. So one is y, for theta is y, for x we use x. Okay. 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 So substitute those input into these two equation and make it into matrix form. Okay. So and then find the characteristic equation. So characteristic equation is basically what we take the determinant for this matrix over here. Only for this matrix, we find the determinant for it. Okay, so find the determinant. So we get this equation, omega squared, and then solve for the roots. Okay, so we have two roots, omega 1 and omega 2. So basically, it is the natural frequencies. Okay, unsolved natural frequencies because we do not know K and M. Okay, but we don't actually need to know what is K and M. Okay. Okay, so using these two, omega 1 and omega 2, substitute into this equation over here. Okay, so substitute into this equation. So so for omega 1, substitute into the previous equation. So we'll have the ratio between y and x. So just make sure that you get the ratio correct. Okay, so if you look at the apa nama, the equation, okay, the equation. So basically here we have so it depends on which one you put at top. Okay, so if you put x on the top, y at the bottom, so these two dia akan terbalik lah, dia akan jadi terbalik. So it depends on it, but then if you put it like this, y and x, so ratio should be y over x. Okay, so if it's the other way around, if you put x to y, so this one will be different and this one will be different. Okay, so basically, I believe the answer will should be the same. The answer should be the same. Means you will get omega the same, but then um, your matrix over here will be different. Okay, so since your matrix over here will be different, so ratio wise will be you get the same, but then um, you cannot just, for example, you put like this y and x, and then you put ratio x over y, so it doesn't work like that. Okay, so you have to follow your sequence over here. So if it's x y, and then so your ratio will be x y. If it's y x, and then your ratio should be y x. Okay. Okay, so finding the ratio. Okay, so based on the omega, so you substitute omega 1 and omega 2, you get one ratio, second ratio. Okay, then you see here you have input 1, input 2. So input 1, input 2. So means bukan input lah, output, sorry, output. Okay, so if you observe, the first one has a positive and positive value, right? So this should be positive, and so R should not be negative. Okay? R memang tak negative kan? It's a radius. Okay. So this one and this one is positive. Now, if you remember the modes, okay, if we give it on the modes, if it's apa, fundamentally or roughly to say, first mode will basically look like this. Okay, so this is the first mode. Okay, so means if okay, first mode. Second mode will look roughly like this. Okay, so means first mode should have one peak. Okay, second mode should have two peaks. Okay, and okay, so okay, so if you look at this, so we have one is positive and positive. Okay, another one is positive and negative, right? Positive and negative. So the input, if we put uh, input of 1, or the displacement of y is 1. Okay, so the displacement y is 1. So the displacement of x will result into this 1.78 r and negative 0.28 r. So if you sketch it, okay, so you have positive and positive, right? So this is actually the first mode. So it means you have only one peak. Okay, you have only one peak. If you look at the second one, you have one is positive, one is negative. If you sketch, you have two peaks, 1 and 2, right? So then this is the first mode. Okay, so with one peak, you have it is the first mode, and the second one with the positive and negative, which look like this. So this is similar to, right? So we have two peaks. Okay, so one for one revolution, you have or one oscillation, you have two peaks. First mode, for one oscillation, you have one peak. Okay, so kalau tengok in terms of waveform, akan jadi sini lah. So one peak for per revolution, second peak per revolution. Ini per revolution dia ada two peaks. Okay, so per one revolution, you have two peaks. So this per one revolution, you have only one peak. So this is the first mode, and then this is the second mode. Okay, So that's the explanation on the assignment. Any question? That's all. Is everyone here?
Sir, how you got the 1.7 just now?
1.7. Okay. This one. Substitute ni. Substitute omega. Substitute this omega into this equation.
Okay, sir.
So substitute omega, and then you get the ratio between y and x. Yeah. So substitute the omega. So for omega 1, substitute in there, so you get ratio. And then substitute omega 2 to the same equation. Look at this ratio over here. Okay, so the ratio that you get is the so one is for first mode, second one is for second mode. So it depends on if you put this as omega 1 and this is omega 2, and then you substitute this first, and then you get so it doesn't mean that this must be omega 1 and this must be omega 2. So it can be either one. But then when you look at the ratio, one is positive, one is positive, negative. And then when you sketch, you get this shape and then this shape. So you know that this is the first mode and this is the second mode because of the peaks. So when you have one, then you have two. So okay. Okay. So, so you can try out different if you want you can try out different sequence or different model, and one is rotation and translation lah. Like, simpler one is just just rotation and sorry just translation. For example, for example. So for example ini lah. For example this one, we have this is two degree of freedom system. Okay. So then but in this case you have force input. Okay, yeah, force input. But then even if you have force input, if you want to find modes, you disregard this force input. Okay, so I think I mentioned before, when you want to find modes of a certain vibrating system, you do not put a force or external force on it. So we determine the modes just based on the natural characteristic of that system. Okay, so because we're using natural frequency. So if you have external input, it might, or you have external modification, it might change the natural frequency. So even if there is so initially there is no external input lah. So initially there's no external input. That external input comes after that. So what we want to find when we how we want to determine the natural frequencies of the system, and how do we want to determine the modes of the system, we only use the the natural aspect of it. So without any external input. So in this case, you again the same process. You derive the equation of motion. In this case, it will be much simpler again, but both translation. Derive the equation of motion, and then what's the next step? Derive the equation of motion, then cuba type dekat tu. Cuba type dekat chat box tu. Lepas derive equation of motion,
put in matrix form.
not yet. Put in matrix form. Better not yet lah. Better not yet. Boleh juga, tapi better not yet. Apa lagi? Mas Lydia, Nadilah. Put consider harmonic, or give the harmonic displacement or harmonic input. So x cosine omega t ke ataupun x sin omega t ke, it's up to you. And then you substitute into the equation. So with the cosine or sine, so if you since you have x dot and x double dot, right? So since you have x double dot, then you have to differentiate and differentiate. Then so then after that, so you have you can put the equation in matrix form, yeah, tadi. So harmonic, and then matrix form, and then
Determinant.
okay, so find the determinant. Okay, find the determinant, basic characteristic equation kan, and then okay. Ya.
Natural frequency.
Okay, natural frequency. Ini jangan tengok calculation, so kena ingat. So equation of motion, harmonic, matrix, determinant or characteristic equation, natural frequency, and then substitute into the matrix, and then you get the ratio between x1, x2, or y or x, it doesn't matter, x1, x2. And then so from that ratio, you can determine whether which one is first mode and which one is second mode. Okay, so when you sketch, you get one will be positive, and another one will be, or the ratio will be 1 to something. Okay, so depends. Then yeah, apa, but for example in this case, in this in this case kalau second, kalau soalan asal dia apa, dia bagi ni natural frequency, M1 berapa, M2 berapa, K1, K2, and actually you can actually simplify actually. So simplify to apa, to simplify between M and K. So since M and M1 and M2 is half, right? So M1 is 2, M2 is 4 kilogram. So actually, the trick here is that you can actually make it as M1 equals to M2. Kita balik. M1 to M2. Right. So M1 equals to M2. So we can actually sort of like make it so this one will be M and this one will be 2M. So both are using M. Then key pun boleh simplify with the ratio. So then when you develop or when you derive your equation of motion, and then when you derive your natural frequency, you will get only two natural frequency with something K over M. Something K over M. So instead of having apa, different M, so M2, M1, M2, so dia akan jadi complicated lah. So simplify by ratio, and then easier to solve. One of the tricks. Okay. Any other question? So for the next class, we are going to do similar revision. So this one is basically the earlier part of the 2-degree reference system, which also part of it is 1-degree of freedom. For example, harmonic and natural frequencies. So nanti we'll go back to the single degree of freedom punya, and then we'll revise on chapter 5 and chapter 9. Okay, so chapter 5, chapter 9. Okay, force input, and then isolation and absorb. Okay. Yep.
Do you about we assume that M2 is 2N? Can we use the same for K also?
Can. You can also use for K. So dia akan jadi apa? Pecahan perpuluhan. So which will make it simpler lah kan. So since you need K and M, so kalau ada 2 or 3 different K, then it will be difficult. So you can simplify.
Okay, sir.
Okay. So Okay, last but not least, okay. So last week, apa ramai tak datang. So mana tadi? Oh, tak ada. Okay, I will post a video that I showed last week to, I think yang datang itu 5 orang ya, 5-6 orang apa, sikit lah, ramai tak datang. Tak sampai separuh kan tu. So last week was the last part for chapter 10. So I want you to watch, siapa yang tak datang itu, especially yang datang pun nak tengok lagi sini boleh je. I want you to watch the video. I will post later. And itulah, watch carefully lah. I will. You don't have to watch all. I will from you watch until which part. But watch carefully, and if you want, you can kalau nak tengok lagi boleh tengok sendiri lah. So that is the last part for chapter 10 lah. Okay. So siapa yang tak datang last week, minta tengok lah. Okay. Kalau ada apa-apa soalan, last week I also gave some explanation while watching the video. But this time siapa yang tak datang tu tengok video je lah. So kalau ada apa tak faham tu tanyalah. Boleh tanya. Okay. Okay, so that's it for today. InsyaAllah next week we are going to have another 2 sessions, right? The 2 sessions next week. Okay, so and then after that, revision week. Then start exam lah. Okay, so so we'll finish the 2 sessions next week with tutorials again. Okay, so that's it for today. Any other question? Tak ada. Okay. So kalau tak ada, we end here. InsyaAllah. So yang di kelas ni boleh bergerak lah. Okay. So thank you very much. InsyaAllah we end today with that big Quran so to us. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
sir.